Testing 1 2 3, 1 2 3. Hopefully everything is working like a banana-rama. Yeah, probably everything working. Welcome back to another freaking stream, everybody. Wait, let me share on my Discord that I'm live. Everybody knows. Okay. Okay, cool. Welcome to another stream, everybody. It's been a minute. I was busy and oh shit. But this stream is gonna be a lab report, finisher, and a quantum practice something. Okay. Enough yabbering. Let's get on the road. If my word online can't even load. Ooh, that rhymed. Okay. Yeah, so the sub counter is currently not working because we're updating the site and a lot of things is coming. Like a lot of things is coming. Now let me see here. If you brother, can I please? There we go. Thank you. Thank you. Thank you. Thank you. Still have my chat up on the side and I can see what the hell is going on. Boom, like this. And mute myself because I don't want to hear my annoying ass voice. Yes, sir. There we go. Everything should be running good. Okay. Let me see here what we got. Okay, so basically this is what I'm working with, and I have to write a conclusion to all this. Okay. 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 Let me write a conclusion to this. Let me see here. All right. Now everything is working. Let me actually turn myself up. Can you hear me now? All right, let's get going. So, oops. There we go. Oh, Trump. What the hell are you doing here? Okay. Let me see here. Oh, be there for you, baby. Oh shit. Just name. Oh shit. What the hell happened? Bruh. My screen just disappeared. There we go, everything is working. Yeah. So many tech errors, bro. Bam. There we go. There we go. Let's get working, baby. All right. Okay, so. Okay, in conclusion, the unknown compound was successfully identified as 1.2 dibromo benzene by combined formation from MS and NM HNMR CNMR shit NMR IR and Wtfff spectroscopy. Each technique contributed different structural information, and together what the spectra matched well with the expected properties of ortho dibromobenzene. I should probably add ortho also, like this. Ortho. The MS. Okay, now I have to write the conclusions to every freaking spectroscopy. The MS spectrum gave some of the strongest evidence for the compound as the molecular ion peak at at M/Z 35.9 match the molecular weight. Weight of what? Weight of ortho dibromobenzene. I should probably okay, I'll do it later. In addition, the characteristic 1.2.1 isotope pattern clearly indicated the presence of 2 bromine atoms. The fragmentation pattern, especially the loss of 1 bromine atom, also supported this. So also supported this. The HNMR and CNMR spectra confirmed that the molecule contained a symmetric desubstituted benzene ring. In the HNMR and MR spectrum, only 2 aromatic proton signals were observed, which is consistent with an ortho substituted structure, where the hydrogens exist in 2 equivalent into equivalent environments. Did I spell environment? Is it in here? Yeah, environments. Similarly, the CNR spectrum showed 3 carbon environments supporting the symmetry expected for 1.2, or sorry, I can just say all for benzene. So this is the HNMR CNMR conclusion. And then I have to write arrows also. Got it. Okay. Okay. Yeah. Okay. I should probably charge my phone while I'm doing this. Then I can have 2 stone, 1 bird. Wait, 2 stone, 1 bird? 2 bird, 1 stone, right? There we go. Oh shit. Oh, it's very, yeah, okay. Oh, here we go. Gotcha. There we go. Okay, let's lock in. Symmetry expected for alpha by yeah, okay. So the IR spectrum further supported the identification of by or of. Does the off showing by showing off showing screw it, showing aromatic C and CBR vibrations, while also confirming the absence of other functional groups, such as alcohols, alcohol, I can't even spell alcohols, amines, or carbonyl groups. Although some expected peaks were weak or difficult to interpret clearly, the overall spectrum still matched the proposed structure. Haha! All right. Slave to the rhythm. Okay, good. So, and fine. No, I shouldn't just end it with finally, right? Yeah, finally, the UI, this spectrum showed absorption bands typical for aromatic pi asterisk transitions, which is expected for a benzene based compound. Small deviations from literature values were likely caused by solvent effects and experimental uncertainties during dilution. Overall, despite the minor experimental errors and limitations, the collected spectroscopic data consistently pointed towards ortho dibromobenzene as the compound, right? Yeah, it's compound. The experiment demonstrated how several spectroscopic methods can be used together to identify and confirm the structure of an organic molecule with, yeah, just like this, like this. Can be used to, I spell used wrong. Used together to identify and confirm the structure of an organic molecule. Perfect. Okay, so now arrows. Okay, so now I have to write the sources of arrows. probably like do it like this. Bam. Okay, so the sources of errors. Okay, several. Why is it? Yeah, sure. Several experimental uncertainties may have affected the quality and interpretation of the spectroscopic data obtained during the experiment. Although the overall result strongly supported the identification of the compound orthodibromazine. Benzene, right? Yeah, benzene. These factors, what? These factors could explain deviation from the literature values and the shit, I wrote that wrong. Values and the reduced clarity of certain spectra. One major source of uncertainty, certain, right? Certainty was the preparation and dilution of the Wtfff sample. The original solution produced an absorbance that was too high for accurate measurement. Repeated dilution of the sample. Since the compound was diluted approximately 5,000 times, even small measurement inaccuracies during pipetting or volumetric preparation could have produced significant errors in the final concentration. Boom. This may explain why the secondary UV vis absorption peak appeared weaker than expected from literature values. In addition, the use of ethanol as a solvent may have influenced the spectrum through solvent effects causing slight peak shifts and yeah, slight peak shift. In the IR spectroscopy experiment, weak signal intensity limited the interpretation of some important regions of the spectrum. The expected aromatic C.8 stretching peak around 3,000 centimeters in power of -1 appeared much weaker than anticipated, and the fingerprint region was not sufficiently resolved to clearly determine the substitution pattern of the benzene ring. Furthermore, IR measurements can sometimes produce lower intensity, such as CBR stretches. Small impurities on the crystal or insufficient contact between sample and crystal surface. Yeah, okay. On the crystal, yeah, just crystal surface. Surface, maybe. I just may also have reduced signal quality. Bam. Cool. Okay. Now the NMR. Okay, so basically the NMR didn't have any arrows a lot, I think. Yeah, I can write this then. The NMR spectra also contained possible sources of era. In the NMR NMR spectrum, the integration values were not perfectly equal, even though the structure predicts two equivalent, right? Yeah, equivalent sets of aromatic hydrogens. This deviation may have caused by impurities, inaccurate baseline correction, imperfect calibration of the instrument, or it can also be contaminated. So traces of solvent contamination. Bam. Okay. Small concentration differences in the sample preparation could additionally affect signal intensity. Despite this, the sharpness and position of the peak still strongly supported the proposed structure. And then the mass spectral yeah. The mass spec for the mass MS spectrometry data, a few peaks appeared at unexpectedly high MS values. Such signals originate from contamination, fragmentation of impurities, instrument noise, or compounds from previous measurements. However, these peaks were small and did not interfere significantly with the interpretation of the main molecular ion pattern. Bam. Several experimental limitations were present. The combined spectroscopic data remained sufficiently consistent to allow reliable identification of the compound as ortho-dibromobenzene. Bam. Is there anything I want to write? No. Let me check. 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 Whoops. Probably. I have to do this also. Bam. What? Now let's do, wait, let me actually, yeah, okay. Uh, mm, mm. My God, it's lagging as hell. Yikes. Okay, let me start with top. Okay, let me actually. Oh my ass. Oh my God, it's a whole shit. Oops. Bro, I can't even. Oh. Oh shit. What? You probably see this, right? Maybe. Yeah, isn't that like this? Cool. Let's get on the road. A bit up. Like this. Ah, we're back with this. Okay. Got some little chalk here. Just chilling. Alright, so first we have to make this figure. Bam, bam. A little bit like this. Okay, that was an ugly ass figure, like. This, boom. This is V0, right? Yeah, V0. And this is 2. This is 3. And this is, oh no. And this is the particle, bam. And it goes down, and then it goes up. And it has a distance from 0 to L. And the energy is weaker than the potential energy. Right? Yeah. And this is just, wow. How beautiful. Wait, let me actually. So we can see that the big potential energy barrier, this one right here, with the constant energy with V0 and what? Oh shit, I'm getting white. No, 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 no. Yeah, okay. So we have to make a Hamilton operator. Bam. Okay. Hamilton TK plus V0, right? Like this, yeah. Oh, go like this. And then this is basically this becomes 0, so this becomes minus h to m the derivative of like this. So now we can make the Schrödinger equation, which is E wave function H, or is it opposite? No. This is the wave function. So now I can use it for the wave function in position 1. It's gonna look like this. So E1 equals minus H bar 2m. The derivative. Hello. The derivative of dx like this. So now we can do this d2 dx equals this bam 2me h bar this. So we want a k value, so k is 2me divided by h bar in second. So we're gonna put the square root on this. So 2me shit me spam. There we go. And then the double differential it's gonna be 2 this. And then if we're gonna solve this, the wave function will be in position 1 it's gonna be a e I k x plus b e minus I k x. As ugly as I. There we go. So this one is positive and this one is negative. So positive, that means it's gonna go to the right. Negative is gonna go to the left, the particle. And for the this one right here, the wave function will be f e I k x, right? Yep. It's pretty like this. There's a lot of space, I think. Okay, so in position 2, we can see that we have a positional energy. And that's why the Hamilton operator will look a little bit different. So this is gonna look like this. Bam. RTK plus V0. Yeah, so for this it's gonna be but no, like I have no idea how I'm gonna remember this without paper. Minus h bar in second, right? No, h bar only 2m. I wrote it there before. No, only 2. Yeah, and then d2 d x wave function of 2 plus v0 wave function 2 plus e, right? Yeah, e wave function 2. Bam. Like this. So now we're gonna pull it like this. minus h, like where minus h to m. This one gets derivative dx, and then you say bam minus e 0 like this. Oh shit, equals 0. So we're gonna multiply this one in. So basically it's gonna be, okay, it's a bit messy. Yeah, so it's gonna be like this. G2 dx2. Right, that's ugly as D. D's not. Like this plus 2me. Oh shit, not e. This one right here, bam, minus 0, and then h bar in second equals 0. I forgot the goddamn equals 0. Now we can get a little function that we can buy, which is an exponential function. I almost started like a motherfucker. So basically we can buy this one. EKX what? No, EK. This can be my. So if we're gonna differentiate this one, we're gonna get in the double differential, we get I think, yeah, we get k 2 to oh, I have hiccups now. Bam, like this. And then we can reroute the whole shit, and it's gonna be like e2 plus 2m e minus h bar in second. The wave function we love, and 0. Like this. Yeah, it's a bit messy. Let me use SpongeBob. Oops, maybe I shouldn't. This one is a good thing to have. So it's gonna be let's do dx 2me, not e. Oh my god, I'm stupid. E minus b 0. No, not 0. Is it a minus? Yeah, it is a minus. God damn it. Okay. So something negative and negative gets positive. So we're gonna write it like this. 2m v0 minus e. Bam. H bar. And then k2 will be a plus minus function. So it's gonna be m e. Am I tripping? No. There we go. That was some beautiful H. I don't know how I made that. Yeah, so that means this wave function, it can either be positive or a negative value. So it's gonna look like this, the wave function on position 2. Oops. CEIKX, right? Nope, I am so stupid. K2x plus DE minus K2x. Yeah. And then my stupid ass forgot to write the, oh my god, okay. Yeah, so we can see that inside the potential energy right here, the barrier, what? Oh yeah, so inside this, we can see that the wave function doesn't oscillate. And it's exponential falling, yeah, because the negative value is more dominatrix. So inside of 2, so the amplitude falls basically. So there's not, yeah, okay, I need to work on that shit. Okay, yeah, let me do question 3 then. Ouch. So we have our Hamilton operator. No, what? Yeah. TK plus V potential energy equals T. Okay, since V potential is 0, so TK equals minus h bar second to m d second dx. Bam, I know this now. And then we'll look at the Schrodinger equation, which is h bar bam bam equals e. Now we can buy this function. So I want to buy this one from the superstore market. E. What the hell did I CX? Yeah. So this is gonna look like this. H 2 M D2 DX2 ECX minus H or 2 M C2 ECX. Then we can see there's an eigenfunction of itself, so it's gonna be my E minus, yeah, minus H or 2M squared. Okay. So that is going to be like this. Minus H bar 2M D2 dx2. Oh shit. Minus E wave function equals 0. Now we can divide it by 2m, so we get, and where do I want to write it? 2 2me what? H bar in second, and then the wave function equals 0. And then C is minus I this 2me h for second. And then for the square root, we can say this 2me h bar in second equals k. Yeah, I'm currently waiting for the thing to refresh. Oh my god. How long did I stream for even? What? I think it's been a 1 hour, I think. Let me finish this and then that's it. That's it. That's it. Okay, so we have two solutions. So we get wave function equals c minus what is e ikx, oh my god, ikx plus, yeah, I'm guessing c2 e minus ikx. So now we can merge those like fusion in Dragon Ball, and so it's gonna look like this. Fuse them two together, so it's gonna be c e1 ikx plus c2e minus ikx. Haha! Yep, and then doesn't look amazing, so we're gonna use Euler's and say e x equals what? What did I write? Cos x plus, right? Yeah, plus sine. And if you yo, what's up, Soak? Hi, do you do chemistry live? Yeah, basically I'm streaming my whole university journey. So like but yeah, I do chemistry live. So if you have any problems, just tell me and I'll help you. But I appreciate you being here, man. Welcome to the stream. So right now you may be like confused. I'm doing quantum mechanics, so I have an oral exam in June. So about 14 questions I have to prepare, and you're not allowed to bring any paper, so it has to stuck in your head. So the only thing you're allowed to bring is you and like a plan of what you're gonna say. That's it. So no anything else. But I appreciate you being here, man. I appreciate you. Where was I? I was getting sidetracked. Yeah. Okay, so we get this one becomes. But yeah, maybe someday I want to stream like chemistry, like chemistry experiments outside and like just have fun with chemistry. But now I'm doing this. So I'm just building up slowly until my audience comes, and then maybe someday, man. It's definitely my plan. But with theoretically, I can. All the best for the exam. Thank you, man. I appreciate it so much. Um, yeah. So I just need to practice a lot. Just need to practice and practice and practice, and then I'll hopefully ace the goddamn quantum exam. But like I said, I appreciate you being here in the chat. Welcome. Hope you like my content on my channel. So yeah, okay, so now we're gonna look at the particle as 0 and L, so we're gonna replace X with L over 0, basically. Equals what, 0? Yeah, 0 plus by sinus. Did I forget something? No. 0. Yeah. So now we know that cosinus to 0 is 1, and the whole of cosinus is 0. This one. So let's focus on this. So let's do the same. Yo, thank you for the sub, man. Sorav Ghosh, I appreciate you, man. Thank you for the sub. Okay, my alerts are working. Amazing. I appreciate the sub, man. Thank you. My sub count is currently not working because we're updating my site. Thank you for the sub, man. I really appreciate it. Okay, so basically, where was I? I was going to do the But yeah, speaking of my site, I have my own website to help every single chemistry student or science student to ace their exams or just ace the knowledge in chemistry. So hopefully you guys can check it out and give some feedback of how it looks like, since it's still in development. But I think it's gonna be big someday. Anyway. So this is gonna look like S1 KL, bam, 0, and then KL, KL, I butchered that, KL equals N divided by pi, no, pi, and N is basically 1, 2, shit, I can't even, 2, 3, etc. Yeah. What's the website name? I will like some chemistry content. It should be in the description. Let me chat it to you guys. HPPS. It's basically called Zanium.net. That's basically so my name and then .net. HPS Zanium.net. But you're so welcome here because this is basically chemistry content. I can't even spell right net. There we go. I texted it in the chat. There we go. Yeah, I'm getting so wide. So now we can isolate K. So K is gonna look like N I M. Okay, thank you. I appreciate it. I appreciate you, man. I appreciate you so much for being in the chat. And I appreciate your existence. And you all just made my day. Or yeah. Absolutely incredible, man. I appreciate you, man. I genuinely appreciate you. Okay, so where the hell was I? Okay, so the wave function. B and shit. I can't even. N pi and then where the hell did I write it? L, right? Yeah, L x span. And then we have to find the energy, which is have the solution E K2 H bar 2, right? Yeah, H bar K2 H bar 2 2M2. 2M only. And then we have different things that goes out to each other. So E H bar, right? No, only H. Okay. H N HML second. Yeah, probably this. So now we're going to integrate our like this. There we go. I can't even draw infinity symbols. Like this. Normalized is 1. And now we can set our wave function inside, which is this one. B sinus N Lx, this one right here. So let's put it inside the integral. It's gonna be like L to 0. I want this one. So this, the complex conjugated of this times the wave function. So it's gonna be like, it's gonna look like B asterisk sin n god damn it, n pi lx, like this, and then the normal b n bam dx equals uno 1. Probably I did like 1. So our wave function is real and there's no imaginary part. So that means the complex conjugated is just itself. So it's gonna look like this. So 1 equals B L0 sinus of n pi Lx dx. And then we can count or calculate our integral. So shit. So it's gonna be like this: 1 b2 L2. Yeah, L2. And then we can isolate B in this thing right here. So B is going to be, BB is going to be plus minus the derivative, the square root of L divided by 2. So plus minus, since there's a negative value and a positive value. So basically, let's take our B and insert it in our wave function, which was this one right here. So basically, it's gonna look like this. We know what B are. B L2. Where is it? B, we know sin n pi L x. That's what we got. Okay, so everything with this particle box can be described conjugated compounds. So we have a molecule. I forgot. Like this. C. Shit. C. Like this, right? No, not at all. Like this. Yep. And then we have one. This. Yeah. Like this. And then like this. And then like this. Bam. So the length of this will be 3R C double bond plus 2 R C, yeah, C single bond and 1 R C single bond. Yeah, 1 R or whatever, makes the same thing. So now a carbon double bond is approximately 135 ppm. Oh, sorry, PM picometers, and single bond is 154 picometers, if I'm right. Yeah. So it's gonna be like 3 times what was 5 PM plus 2 times 154 plus 154 ppm. Units are pretty important, so never forget those. And that gives us 867 PM. Shit. PM. So now we have the formula. Let me write it here so I don't forget. En 8 ml second. So now we can use what delta of E equals X minus the ground state, GS. But I can't even. Slate. Can I get my equation, or like what? Like, can I get my equation, or there we go. Ah, yes, this is what I want. So buckle the frick up. It's gonna be a long So basically this one I'm gonna use, okay? So it's gonna look like 6. That's pretty much no. 6 to 6 Planck's constant. Freaking Planck. I really want to collab with Planck, honestly, bro. Like a stream with Planck. Holy shit, it will go numbers. I'm telling you all. 3, 2, bam. And then we have 8. 8 times the m, which was what? That was the mass 9.11 10 power of minus 31 kgs, since it's mass, and then we have the length, which was this one. So 8, that was an ugly ass 8, 8, 6, 7 p.m. squared, which gives us a energy of 7.1.21 10 the power of minus 19 joules. Bam. And then we can do it the same with E4, but it's gonna take a long time. So basically E4 gives us approximately 1.28 times 10 powered by 18 joule. Yeah, and then we can use this one. So E gives us a 5.61 times 10 the power of what? The 19 joule. Yep. Sweet. Okay. Ouch. Ouch. I'm hurting myself. Okay. Yeah, that was pretty much what I wanted to do. There we go. Got chalk all over my fit. Actually, I want to show you guys what I'm. Okay. So actually, guys, let me show you before I end the stream. Let me show you what I've been working with on the website. Wait. There we go. Getting my chat. There we go. Okay. Let me see here. Now, buckle the frick up because this is going to blow your socks off. I'm telling you. Oh my god, like I'm having a feeling this is gonna be big. Like it's definitely coming. Pause. Just currently doing the. All right, can you see this? This is basically the website. We are basically working to create a website that will be so ultimate that everyone will know about it and every single chemistry student will use it and can like help themselves with chemistry. This is basically a good tool to help you with chemistry, basically. So I think I did it last stream, like explain what the hell is going on, but this is the front page basically. So nothing more exciting, but we're definitely gonna improve that so the first impression gets more better. Then we have the stats, like just the stats. So but yeah, 58 subscribers. Holy shit, almost at 90. That's incredible. I really appreciate you guys a lot. Like the support has been massive. And yeah, just everything in one place. So you got chemistry games, periodic table, molecule simulator, learning molecules, community, and then pro plans. So this is just one of my recent videos, so you can watch that. And then we have a premium feature. It's not in yet, so it's getting developed, but there's a lot of features coming. So we have videos, like just videos, like all my YouTube videos, all that. Yeah, we all have that. And then we have, okay, I'm lagging like a motherfucker. So we have tools. Yeah. So every toolkit Xenium offers, from free calculator to AI-powered pro features. Hi. Yes, sir. Okay. No problem. Okay, let's just ask to close the window. So give me a second to do that. Is this working? Yeah, okay, this definitely doesn't work. So this is the channel growth. Wait, I'll close my window. I'll close the window. Wait. Oh, like this, right? Yep. There we go. Closing the window. Oh yeah. But yeah, a lot of things coming, like a lot of functions, a lot of things. So this is just the start. And I'm so glad for you guys. This is exactly what I'm looking for. Do you have specific stuff for organic chemistry? I struggle a lot in. My friend, there's gonna be so much for organic chemistry, for analytic chemistry, for medical chemistry, for general chemistry. Every single branch of chemistry is going to be on the website. And every single, like, I'm gonna cover on my YouTube channel, I'm gonna cover every single topic there is on organic chemistry for free and for a simple, like, so simple that you can do it with blindfold. So I'm definitely gonna cover everything, all the chemistry topics. So after I'm done with organic chemistry, I'm gonna be doing general, and then I'm gonna be doing like every single inorganic compound there is, and then just slowly work on top. You feel me? So I'm gonna be the ultimate chemistry creator streamer there ever lived. Okay. So this is just the live stats, like I showed you. That's pretty cool. That's just for me, basically, for my stream, so I can have my own subscriber, like a subscriber count without using YouTube. So gotta be more creative. This thing is still in development, so the thing is not working yet. Oh, actually, wait, it does work. So yeah, it's just a little easy way to navigate. So we're gonna have lab notebooks, and it's gonna be a lot of things. So let me show you guys. We have learn table, learn chemistry, basically small. This is still in development. Don't worry, it's gonna be a lot. And so different topics. Then we have the periodic table, everything from boiling points to, and you can compare also. And then we have simulations. calculations, all the calculation. We're definitely gonna improve more. Don't worry. Unit converter. This one is pretty cool. I'm not gonna lie. Formula reference. So all the formulas you need. Pro AI tools. So a reaction predictor, a spectrum analyzer, and a paper summarizer. So that's really good. So if, for example, if I want to write like, yeah, definitely something, but I'm not gonna touch it yet because it's still in development. So exam generator, so you can generate your own exam and practice. So you can extreme level, easy. Nuclear chemistry also, chemistry Olympiad. Every single branch of chemistry is coming. Don't worry. So yeah, that's. And then we have flashcards, a lot of flashcards you can practice on. There's gonna be a thing where you can create your own flashcard on the website for free because I want to take justice of Quizlet because Quizlet just want us to pay for creating your own flashcard. Like, what the hell? So it's better to make it free. So that's what I'm gonna do for this website. So every student can create their own flashcard for free and just have fun with it and learn. And then we have the molecule viewer. So we create this from scratch. Every model is created by us. So yeah, definitely like still in development, but it's pretty cool to have. Then we have the Xenium AI, which is an AI tool. So it's an AI tool that will help you with chemistry, mostly focused on chemistry. So yeah, then we have the games. This is my favorite part because learning chemistry is more fun when playing games. So we have a lot of games, a lot. Like you can check them out if you want. But yeah, there's gonna be a many more in the future. Don't worry. So we're gonna develop more, and then we have plans. So basically, we have Xenium Plus, Xenium Pro, and Xenium Ultra. So you can read about it, what you will achieve in what tier, and honestly, it's really cool. And yeah, hopefully it's gonna work out. And then we have the ranking. This one is pretty cool. So you can log in, you can make your own account, and you can like have badges like a game basically. You have badges, like trophies, your stats, your exam history, everything, like making your own personal thing. Then we have a lab notebook. I have no idea what it's going to be, but it's like just a digital notebook you can have for free. And then the social media, all my social medias are here. If you want to follow, if you want to be part of the community, I appreciate you a lot. And yeah, honestly, and then we have maybe merch is coming. Who knows? In the future, I'm definitely gonna develop merch, but from now, just here. And then you have about me. So everything, what I stand for, what I do, why I'm doing this, and basically just what the hell I am. Yeah, that's pretty much it for now, but we're definitely gonna improve more things. So stay tuned on this website. This will be big. I'm saying to you. This will be pretty much big. But yeah, hopefully you guys will enjoy the website and my content on YouTube. So yeah, it's gonna be good. And also maybe enjoy my series I'm making, my like personal series called Training to Marathon, since I wanna practice or train to a marathon, my first ever marathon. So that's pretty much it. And yeah, do I have anything else I wanna say? No. I did what I had to do. But yeah, definitely a lot of things coming. So it's incredible that this is a dream come true, this whole website thing. So I definitely want to thank my developer, Joxy, for making this happen. So Joxy, if you see this, I appreciate you so much. And I can't wait to change the world with you, honestly. It's gonna be so good. Um, yeah, I think gonna end. That's pretty much it. I wanted to stream because I want to have my streaming consistent and not miss one day. Just work and work and work and work. And hopefully, you guys, I hope you enjoyed me. Um, I have an exam coming up. I'll be using this. I just wanted to say this is such a cool website just from the looks of it. I appreciate you so much, man. I appreciate it so much. I really appreciate if you could spread the news or spread the website to your friends or your family or something like someone who is interested in chemistry and just spread it around the world. That will mean a lot to me. So I appreciate you, and this is basically for you and everyone, all my students, like all the students around the world. And we also have developed every single language there is on the website, so no one is basically having a hard time to figure out where the hell they are. And yeah, it's just they can feel at home basically. But yeah, I appreciate you guys so much. Thank you for watching. Leave a like and subscribe. No, I'm um. I'll see you next stream. Honestly, it's been fun. Um. Yeah, it's been fun. I'll see you in the next stream. Eat well and stay hydrated. I'll see you, man. I'll share this with my friends who have a love-hate relationship with chemistry. I appreciate if you do. I appreciate you so much if you do, man. I appreciate you so much. Please, please just spread it out and make a lot of people know about this website. Yeah, eat well and stay hydrated. I'll see you in the next stream. How the hell do I end?